Howdy guys. So week 6, lesson number 2 of 3. On Friday we'll have a live one. I don't think you'll need live at the moment. I imagine looking at your homework there, most of you seem to breeze through that fairly easily, and I think you probably this whole chapter you will, but it gets a bit more difficult as we go along. So what we'll do is we'll have the live class on Friday. We should finish this topic by the end of the week, and then on to the second chapter in the book on measurement. And then we still have a meeting with Miss Connolly and Mr. Pryor, and we're going to decide then whether to abandon this for a while and go to CBA 1, or we're not, or we're going to keep going with this and leave CBA 1 when we go back. It doesn't really matter, and we still have to finish the course and do the CBA. So whether we do it now or we do it when we get back, doesn't really make much of a difference. But I'll let you know that. I should know by Friday what we're going to do with that. Okay, right. So let's go back, look at the homework, and introduce one more thing, and we'll call it a day. So you'll see here, there's 3 exercises I asked you to take a look at since Monday. These ones here, I'm not going to do these. These are really straightforward. You're using this big table here. So you're using all these measurements up here to answer all these conversions. But I've put the solutions in beside. So if you're going from meters to centimeters, you just go this way here, you're doing the 100. If you're going from centimeters to meters, you divide it by 100, and so on. And it kind of has them all done out for you there. So I'm not going to bother correcting all those. You can tick those on the homework so I can see that you've corrected them. Okay. Same with the second exercise was all to do with finding the area of different ones, but we will go through them nice and quickly, for the sake of completion. So I asked you to start on question 4. Now I have put the solutions, so if you're looking for the solutions, they're all out there for you in case I go through this too quickly and you want to figure out any one of them. So there's question 4 and so on. They're all out there for you. But let's have a quick look at them as we're going along. So we see a lot of you would have done area in random other subjects through the time anyway. So what I would do with question 4, you're looking to find the area of it. So what I would do, I would personally close off this shape here. I get the area of this, so 2 by 3. So the area in here is going to be 6 centimeters squared, and then find the area of the bottom one, which is going to be 2 by 8. So this is going to be 16 centimeters squared. 16 plus 6, which is equal to 22 centimeters squared. That's what I would do for question 4. You might, now if you want to really confuse yourself, you could try and draw a line down there, and a line like that, and you can find the area of this bit, and this bit, and this bit, and add them together. So there's a few ways of doing it, but obviously the obvious way is to split it in half, find them up here, then find down here, add them together. But it's up to you. Same with B. The hardest part is kind of figuring out what do I have to do, or I suppose where do I close off. I think the obvious one for me, you could draw a line going from top to bottom here and find X and Y, find the area of those two, add them together. I like to get rid of the smallest one, so I'm not going to do that in my way of doing it. The solution might do it both ways, I can't remember. But if I put a line across here, and we know that over here is 7, and this side is 9, so this is here is going to be 2. This here is going to be 2 centimeters. So I can find the area of this small one is going to be 5 by 2, which is 10 centimeters squared. And then the area of the smaller box is going to be 7 by 14. So you're going to have 7 by 14, which is equal to, what is 14 by 7? I don't know, to be honest with you. So just work that out. 14 by 7 is 98. So 98. So our total is going to be 108 centimeters squared. Okay. Finish off 4. Well, I thought that's 4 done, is it? Yeah. No, 4 is here. The rest of 4 is here. So this is how would we do this one here? Well, we know that this length here is 4. So here's 4. Here's 5 and there's 2. So there's a couple of ways we could do it. We could close off this one and close off this one, and then work out the area of here, here, and here, and add them together. That's probably the way I would do it. There's probably other ways of doing it. So to work out the area of the first part is going to be 2 by 5. So this is going to be 10. This is going to be 2 by 7. So it's not by 5. I'm wrong. This is not 10. I'm after taking, see what I'm after doing there? I'm after taking this length, and I want this length. And I'm wondering, well, if this side is 7, this side is 7. So the actual length is 2 by 7, which is 14. And this one's 14. And the middle one then is going to be, well, we know 2 and 2 and 4 is the total length. So we can work that out then. 4 plus 2 plus 2 is going to be, so this whole length here is going to be 8. But all we need to know is the middle part there. So we're thinking, well, what's the middle part there? Well, if the whole thing is going to be 8, this is 2 up here, this is 2 up here, this is going to be 4 in there. They actually give us that, I don't know what I'm doing. They give us 4. And because this is 7 and this is 5, that means this is going to be 2. So you're going to have 4 by 2, the middle works out as 8. So to work out the area of the whole thing is going to be 14 plus 14 plus 8, 28 is going to be 36 centimeters. Sorry, not centimeters squared. Read the question. Meters squared. Okay, any question that you can ask, or look at the solutions, probably quicker. For each diagram, find the area of the larger rectangle, the smaller rectangle, and by subtracting the two areas, find the area of the coloured region. Okay, so the area of this rectangle is going to be the smaller one. 5 by 2 is going to be 10 centimeters squared, and 11 by 7 is going to be, the green one is going to be 77 centimeters squared. So you're going to have 77 minus 10, which is equal to 67 centimeters squared. This one's the same. We're going to calculate for this one. You're going to have 70 by 80. Hang on, 70 by 80. It's going to be 5,600 for the small one. And remember, this is, be careful, these are centimeters and these here are meters. So this is going to be 100 centimeters and this one here is going to be 120 centimeters. So just be careful there. That's the trick in this one, isn't it? And realize 1 centimeter is 1's meters. So we're going to multiply 100, multiply by 120, which means the outside, the pink part is going to be 12,000 centimeters squared. Then you're going to have 5,600 minus 12,000. Sorry, 12,000 minus 5,600. And that's going to give you your answer in centimeters squared. So I'll do that for you. 5600. It's going to be 6,400 centimeters squared. Okay, I assume those answers are correct. I haven't checked the marking scheme. Okay, question number 8. Is there any need for us to do question number 8? So question number 8 is looking for the area of a rectangle is 72 kilometers squared. So they're giving us the area this time. The length is 9 kilometers. Find the width and then find the perimeter. So find the width and then find the perimeter. So if we're to, did we do that the last day? No, we didn't. Okay, so the area of a rectangle is 72 centimeters squared. The length of the rectangle is going to be 9. Right, so here's our rectangle here. And the length is going to be 9, so 9 kilometers. So it's obviously a very, very big rectangle. The area is 72. So we know to find the area is length by width. So we know that length by width is equal to 72 kilometers squared. So 72 kilometers squared. Or we also know we've given us the length. So we know that 9W is equal to 72 kilometers squared. So we can work out then what the width is going to be. So the width is going to be 72 over 9, or the width is going to be, let's do that on the calculator for you, is going to be 8 kilometers. So now we know 8. What else did they ask us to do? The width we worked out. Okay, there's our width, there's part A done. Now the perimeter, remember, so the perimeter, I'm not going to do this for you. The perimeter is going to be 9 and 8. And because you know 9 and 8, it's going to be 8 here and 9 here. Add those 4 sides up, and that will give you the answer there to part B. Okay, so 9 and 8, 9 and 8, 18, 30, 34. Okay, on then to question, what was the next question? Question number 10, I believe, was this one here. Very similar again, isn't it? Question number 10. So what they're asking you in question 10, rectangular plot of land 320 metres long, they even give you the diagram, and 180 metres wide. I'm just highlighting them with the diagram for you. A rectangular shop is to be built on the land measuring 130 by 85. So here's our shop here in the 130 by 85. The rest of the plot will be turned into a car park. Find the area of the plot of land. Okay, so the area of plot of land is going to be 320 by 180 is equal to 57,600, and it's in meters, isn't it? Meters squared. Area of the shop is just 130 by 85, length by width again. 130 by 85 is 11,050 meters squared. So the area of the car park, remember the rest is going to be a car park, so we just take one away from the other. So we take away our 57,600 minus 11,050, which gives you 46,550 meters squared. And planning regulations for the area require a further shop to be built. Its area must be less than 20% of the total area of the plot of land. Okay, so the area of our shop there must be less than 20% of the whole plot of land. Does the shop meet the requirements? Okay, right, so we're looking for a percentage here. So right, well, we take the area of the shop first. The area of the shop is going to be, what did we say in the part B, is going to be 11,050. And the area of the total piece of land was 57,600. We multiply that, change it to a percentage, 100 over 1. Remember, this has to be under 20% or it's a no-no for the shop. So let's bind it into calculator. Hang on. Okay, yes, just about. That is coming out at 19%. So the answer to that is going to be yes, just about. Okay, question number 11, which I think I might have done for you pretty much. Yeah, I'll leave 11. We'll just skip back on the number 12. Anyone can't finish off 11. I think I showed you how to do it the last day. So something similar again. You can see why I'm flying through these. I'm sure most of you had, and I saw that most of you had no problem with this. A landscaper plans to plant a lawn in a garden as shown. The rectangular lawn will be 12 metres wide and 6 metres, 12 metres long and 6 metres wide. So there we go, there's a 12 metres long and a 6 metres wide. It's surrounded by a uniform path of width 2 metres. Okay, so the path is 2 metres. This word here is important there, uniform, which means it's 2 metres all the way around. Because that can come into the question. Are we assuming that the path is 2 metres? Or telling us it's uniform. So it's the same all the way around. Area of the lawn. Okay, so our area of our lawn is just going to be 12 by 6. Okay, 12 by 6, which is 72 meters squared. Area of the garden is just going to be area of the garden plants, lawn in the garden. Okay, the garden's the whole thing. Okay, so we've 12 here, and we know there's going to be 2 here, and there's going to be 2 here. So in total, it's going to be 14. So the length, the whole thing is going to be 14, and the width is going to be 6, and there's going to be 2 here and 2 here. So it's going to be 14 by 8. 14 by 8, which is equal to 112. 40 by 112, isn't it? It's going to be equal to 112. 112 meters squared. The area of the path. So the area of the path Area of the path, area of the path. Okay, right. So we're going to have to find the area of the path. Now that's a tricky enough one because you're going to have, and the only way I can do this is to separate it into 3 different shapes. So I can do a shape there. So there's going to be, I'm going to find the area of this bit here. I'm breaking it up. And you might find a different way of doing this, but I'm going to find the area of this bit here. I'm going to find the area of all this bit here. I'm going to find the area of all that bit there. So I'm going to find the area. You know I'm not going to need to do that. If I find the area of one of these parts, and I find the area of one of these parts, I can multiply my answer by 2. So let's try that. Let's try and find the area of this full part here. Okay, so area of the path. So we know the width of the path is going to be 2. So we're going to have 2 is the width by the length, which is our 6 plus 2 plus 2, 2 by 8. And then we're going to find the area of one of the middle bits. That's going to be 12 by 2. So I'm after finding the area of, let me just get all this stuff off this so I can show you what I'm after finding as I go along, right? So I'm going to find the area of this bit here. There's my first rectangle. So that bit of the path. And I've done that by doing 2 by 8, 6 plus 2 plus 2. The second thing I'm going to do, I'm going to find the area of this chunk here in the middle. This chunk there in the middle. And that's going to be 12 by 2. Okay, and then you can see, then have a look at the rest of it. The rest of it, so I basically what I've done is I've gotten half the path. So what I'm going to do then is that I'm going to assume that if I work out what I've done below and double it, that will take into account the rest of the path. So 2 by 8 is 16, 12 by 2 is 24, 24 and 16 gives us 38. And double that, because I've only done 2 of them, is equal to 76. 76 meters squared. Okay. The last bit, find the cost of having the path if paving costs 12 euro per meter squared. So, well, we have 76 meters squared in total. So if it's going to be 12 euro per meter squared, and we have 76 meters squared, we're going to have to do 76 multiplied by 12, which is equal to 912. What's the question? Cost. It's going to be 912 euro if you want to pave the path all the way around the park. And you can check by figures there against your own and against the marks and so on and so forth. Okay, the last thing, I know this is taking a bit long, the last thing I asked you to do is this netting thing. Now, I've never seen this asked ever, right? But it is on the course of something that could be asked, so you never know. So I just gave you 2 of them to take a look at. Question 4 was the first one. So question 4 kind of gives you this this bit of a cuboid done. So you have a side and a width. I'll just actually show you the marking scheme. So what they want you to do is draw 2 nets that could make the cuboid. So 2 nets that could make a cuboid. So what you have there is one edge and a side edge to it. So you might have done this in tech drawing and just tech drawing. So I have the solution to this out here somewhere. So there's your 2 answers there. So the black bit is the bit that they give you in the question. So there's your bit that they give you in the question. And you need then another end, a top, a bottom, and another side. So all they've given you is a side and an end, and you have to create it. But there's another way of doing it. Here's the bit that they gave you originally. And then, but they've given you the same thing. So you need the same as that again, and then a top and a bottom. There's 2 ways, and there's an example of that exactly the same above to have a look at. Only other one I asked you to do was I asked you 7 as well, didn't I? So question number 6. So question number 6, and this is more likely to come up as a question. Write down the values of P, Q, and R. Okay, the values of P, Q, and R. So if we have a look at our cuboid, and you know that on a cube or a cuboid, the top is the same as the bottom, the side is the same as the side, and the ends are the same as the ends. So it's two opposite sides are the same, two opposite ends are the same, and the top is the same as the bottom in all measurements. Okay, so if I want to put that into something English, this here is the same as this here. This here is the same as this here, and this here is the same as this here. There's our 1 is the same as 1, 2 is the same as 2, and 3 is the same as 3. So if I'm to look, they're asking us P, Q, and R. So P is the length of here. So here's P here, which is going to be the same as this length here. So P is going to be equal to 10. Q, where's Q? So Q is the width of the base. So Q is the width of the base, isn't it? Yep, so P is 10. So Q is the width here. So Q is going to be equal to 3. So Q is going to be equal to 3. And or, where's or on this? Or is this bit here. Or is the side part here. Or is going to be equal to 5. So this is real spatial awareness, isn't it? Figuring out, right, when you fold up this one here, where does each side go when you have them folded up? Yeah, so it's a real kind of it's more of a thing you see in a newspaper than an actual maths question. But and some people are brilliant at these and some people are dreadful at them. I'd be somewhere in the middle, I think. So question part B then. Part B is something similar, P, Q, and R. Okay, so for part B, or where's R first? Or where's P first, even? P is going to be equal to, so here's P here. There's your base. Your base you can't see, your base is underneath. So P is going to be up here somewhere. So that's going to make P is the 5. Q, P, Q, and R again. Q is going to be, where's Q? Q is here. So Q is going up to the top. So it's going to be here, which makes it's the same as the bottom. So Q is going to be 4. And R is going to be the third measurement, which is 6. Okay. And part C is something similar. So if you make that cuboid, again, if we're in the classroom, I'll be giving you measurements, getting you to make and sellotape your own cuboids, and then figuring out what bit goes where, but we're not. So part C, we've P, we've Q, and we've R. So P is going to be, well, it's the longest side, isn't it? It's the longest side. It's going to be 10. Q is going to be, so Q is the width, so it's going to be 6. And R is the shortest one, obviously, which is going to be 4 centimeters. Okay. Last one. I kind of circled a bit of this. I must have done the last day before I gave you the homework. So what they're asking the last one, the net of a cube is shown, A to N. Identify the vertex or vertices which will meet the given lettered vertex when it's folded back into a rectangular solid. So when you fold this yoke up, what meets what? Okay, so obviously you're going to have the L and K and the C and D are going to fold up, and the rest is going to roll up into a ball down the center. So looking at that there, I is going to, so where's I? So I is here. So we think where's I going to go? Well, this part here is obviously, so this whole part here is going to be the top, isn't it? If this is the base, then this one's going to be the top. So when I fold that right over to the top and move this over at the side, it's going to land on K. If that makes any sense at all. Again, if you drew it out, if you actually wrote it out and cut it out and label them, then it would make more sense, but it's going to land on K. Part B, D So if I fold D, so the side CD and the side LK are going to fold up and become the left and the right side of this cube. So if I fold D up, and bear in mind, the bit that I have the square around here is going to fold up as well. D is going to come in contact with F. Because imagine F is going to be the front wall. So F is going to be a front wall, and D is going to come in contact with F. Or FI is going to be the front wall, and CH is going to be the roof. So difficult enough to manage. What about CG? CG, where's CG? So I'm going to write all over everything. Let's get rid of some of this. CG, where's CG? Let's make it a bit clearer. So, CG. Or not CG, I'm looking at A. A is here. So A is here. So if I fold A up and fold C, remember, so A, this side is going to come over this way. This is going to come in here. This is going in here. And both of these are going up that way. So you can imagine where A is going to be the side here. So it's going to be a side wall. AN is going to be the side wall. So when A folds up and C and D come over, A is going to come in contact with C. And also, what's going to sit on top of A as a top is G. That's what I was thinking ahead of myself. C and G, like that. So it comes in contact with two things. Okay. Moving on slightly, right? I won't keep you much longer. Just another bit of terminology. You have things called a surface area. What it means is, if you have a cuboid like this, all the outside is the surface area. So basically what we can do is we can find the area of all the outside surfaces. So in a cube, you have a top, two sides, a back, a base, and a front. So basically, you have a top and bottom, two sides, a front and a back in a cube. So if I was to put those in, a lot of them you can't see. Obviously, your bottom is under here. Your front side, your side, your top, and in behind here, you're going to have another side. Okay, or a back we call it. We just call this front and back. So you have front, you have back, you have two sides, a top and a bottom. That's a cuboid. And if we want to find the surface area of that, we have to get the sum, add up all the area of all six faces. So I have to get the area of the base. Area of the base, length by width. Area of the side, length by width. Area of the side, length by width. Area of the front, length by width. So on and so forth. And then I add all of those up. The clever mathematician does one side, one base, and top or bottom, and multiplies it by 2. But it's up to yourself how you find the surface area. Now here's an example of one done out. So it's done out slowly. I'm not going to go through it. Find the area of each of the solid faces. So find the area of each of them. Add them up to find the surface area. And you can bring this into a formula. So you could do 2 times length by breadth, 2 times length by height, and 2 times breadth by height. So if you think of a cuboid, you can do length by height. If I want to find this one, if I want to find this one, it's going to be height by breadth. If I want to find this one, it's going to be length by height. So I can find the area. So this is just putting it into a formula. 2 times the length by breadth, by 2 times the length by height, by 2 times the breadth by height. But if you're asked to find it, do it the old-fashioned way. Find the area of all the sides, add them up. And that's another one again. It's just another example. The surface of a rectangular solid is 1,200 centimeters cubed. So they gave you the surface area. Find its height of its side. If the length is 18, the breadth is 15. So they say, right, the surface area is 1,200. So by using that formula, you can, if you think what we have already, we have the length of being 18, and the breadth has been 15. So if you sub it into this formula here, which I give you up here as well, you can work out the missing. So the only thing you're missing there is the height, which is there a couple of times. But you have twice the length by breadth, by twice the length by height, by twice the width by the height, and it gives you the surface area. And you do a bit of algebra to work out the height is 10 centimeters. The basic algebra for you guys, no bother. Same there. Same idea again. The surface area of a cube, let's put a few of the examples in from the book. Surface area of a cube is 864 millimeters. Find the length. So you know that, okay, well, if it's a cube, all the lengths, so we don't need length by width by height, we just need length. And 6 of those lengths is going to be 864 squared. And if you know the length squared is 864 over 6, that gives you the square root of one side, get the square root, give you 12 millimeters. Okay, so the only thing I want you to do, because that was quite long, I want us to work on exercise 20.4. We're nearly there at the end of this first topic. We will finish it on Friday in the live lesson. So what I want you to do, I want you to do questions 2 to 8. So I'll mark them for you for lesson 3, 2, 3, 4, 5. They're very short. It'll take you no time. It's only multiplying, addition, and so on. So I'll put it here beside you. Homework due Friday. Exercise 20.4. Questions 2 to 8. Okay, so if you could have that uploaded before our lesson on Friday, and we'll fly through those. We'll leave the call on Friday and go through the revision exercise nice and quick, and then we will. I'll introduce the second chapter on this. But I know that's kind of seems really quick, like 2 classes for a whole chapter, but you know, you're too strong a class to be messing around with stuff that you're well able or is beneath you at this point. So we'll keep going and clear as much of this. And the more we get done now, the more time we have for revision in the summer, and the earlier we finish the course next year when junior sets are coming around. Okay, right, have a great day everyone, and I will talk to you at 10:40 in a live class on Friday. Mind yourself, bye-bye.